Hi everyone, welcome to this new video lecture of AutoCAD. In this lecture we will discuss how to draw parabola by eccentricity method. So before going to draw, let's see what is this parabola and what are the types of parabolas are there. So parabola actually when you cut a cone, or you can say this is the cutting plane is there, this one the cutting plane, let me highlight here. So this is the cutting plane is there. If this cutting plane is cut the axis of a cone with some angle, and finally what kind of view you can identify in this side, that will be called as a parabola. Now see, this is the cutting plane is there, and it cuts the conical section, a cone. This is the generator of a cone actually. So then what kind of object will get? So this kind of part will get, sectional part we will get here. So that is called a parabola. Okay, so the inclination of the cutting plane is equal to the half of the apex of angle. This is the apex of the cone, and this angle and this angle, so both will be equal, that is theta and alpha. And to draw this parabola, different methods are there actually. So the parabola can be drawn or constructed in different types. So one is eccentricity method, another one is offset method, another tangent method, another one is oblong method. In the oblong method actually rectangle and parallelogram method is there. So here today we will discuss about how to draw a parabola by eccentricity method. So the questions given in such a way, actually the definition of eccentricity is actually the distance of the point from the focus point to the directrix point, and the distance of the point from the directrix. So that is easier actually the eccentricity. So focus point and the directrix point from the distance from the directrix point, that is your eccentricity. So the questions will be given in such a way: draw a parabola when the distance between its focus and directrix is 50 mm, and also draw the tangent and normal at the point of 70 mm from the directrix. So tangent normal, it is quite simple. Previous lecture also I have completed. So let's see how to draw a parabola by eccentricity method. So let's go to the AutoCAD and create a drawing space for us. So MB setup and paper space no, unit M and scale factor 1, 420 and 297. So here I have drawn a drawing sheet for the diagram. So now let me select the line here and just draw a line here, arbitrary line you can draw it here, and another one from the center point of the line, just to draw another one perpendicular line here. Okay, and this is actually the directrix of the object. So first one, the directrix of the line, this one need to be drawn arbitrary length, there is no distance for this, and from the midpoint of this we can draw another one line, that is AB point, and the distance is given, that the focus distance, focus point, and from the directrix point, this is a directrix, and the focus length is given 50 mm. So from this we need to take a distance of 50. So again we can select this side, we can take 50 and give a point on this focus point, and we can mark it here. So text we can give. So this is our height is 3, angle 0, and so this is D point, and this is our D dash point, and this one we can give our F point. Okay, and this is our A, and this is point B right now. Okay, now this line again we need to divide into two parts. So what we can do, this is the total length is 50, so one more 25 mm distance we can draw here, we can join it, or else we can go for the divide command again, simple, and select this object, select this line, make it 2, so division completed. Okay, and this is the V point, this is the V point. So just copy the text and just you can paste it here, and this is our V point. Okay, now we need to draw the line here actually. So what I'll do is I'll just copy this line, directrix line, from this point to, okay, let me copy, select this line again and just copy, CO, enter, select this point I can keep it here. Okay, yeah. Now this is the next part. So from here we can draw that line here, and next we need to just draw number of lines arbitrary from this point. So that way what we can do, so similar kind of line I can do number of lines here this side, both side. So what I'll do, I'll just select this line and I'll just offset O, enter, and throw. So now it is asking this side how much distance, 10. Okay, and select the offset object again 10 we can give. So again just select it 10, some distance we can give, and we can draw some arbitrary lines. Okay, there is no compulsory bound on this, so we can draw number of lines. Yeah, and this side line should not be cross this V point. Okay, V the last point here. So few lines I have drawn here. Now what is the procedure is there, we need to draw arc actually from the focus point by taking the distance from A to different lines. So here also we'll give some names of this each line. So just select this, and we can give a first point here. Suppose this is the first one, and this is second, this is our third, and this is 4, 5, and this is 6. If required, more we will give the later. Now the next step is, so this how we completed 50% of this diagram. Next select the arc and take this is the center point A point, distance from A to 1, distance A to 1 point. Now these things need to be, center point need to be changed to focus point. Okay, this is the focus point. Now see this circle where it is meeting the first line. So this is the meeting point of this one. So just keep this point, highlight this point. Okay, now again we need to just go back to the original position of A point. Again we need to extend the line or circle radius to A to 2 point. Again we need to just change it, the center point, from A point to focus point. So now we'll see where it is meeting second point. So PO, enter, one top, another one is at bottom side. Okay, so next similarly we just need to change the location of this, and we can give up to F point and just drag it here, and we can give the point here. Okay, similar way the same repetition should be done. Again just need to change third point, and from here to again F point, PO, enter. Okay, and this side again bottom side. So similar process again, go to the center point O, A, and move it to fourth point, and now the center point need to be changed to focus, F point. Now PO, enter, and here similar way we can change it up to A point, change the distance from 4 to 5, again move the center point from A point to A point, give the point at the fifth one, and one more line is there, that is 6. So let's complete this. Now again change the center point from here to here. So PO, enter, and PO, enter. Okay, now this circle is not required for us. So we got all these points here. So what we'll do, point style we can keep it the same, or you can change also. There is no restriction on this. Now we'll go for the spline fit, and we can start from the V point, or you can start from any point. Actually you can start from here also. So from top, from bottom, or from the V point we can start anywhere, just to join all this point what we got here. It should be kept like this. Enter it. Okay, and now this arc, just change the color and give the thickness of this. Next we can delete all these points, these lines, by trimming command. Just to trim. Yeah. So next we need to give all these points what we got here. The naming also you can mark it. This one you can give P1, P2, all these names, text, single line text. So similarly, this is how P1, okay, and P2, this is our P3, and is not P3, that is F point actually, this is P3, and this is P4, and this is P5, and this is P6, and this point we can delete it. Okay, now we need to give the dimension. So the linear dimension from here to the focus is 50, so that we can mark it. And this tangent normal also we drawn already previously in the previous lecture while doing the ellipse or parabola we did. So that video you can refer it to draw the normal and tangent by the eccentricity method. Actually that one I have completed during the ellipse lecture. So it's quite simple. The ellipse distance is given, so we need to take the distance from this directrix point to any one point of this and join the focus and draw a 90 degree from here. Like from here to here you draw a line of 70, take any one point on this arc and join the line to the focus point, and then draw a perpendicular to this, and from there we can join that. It's quite simple actually. So now see, here it is taken 50. Now another line we need to select actually. You just take from here to, how much is there? 70. Yeah, 70 means this one, P4 point actually. So this is the distance of P4 point, already is there here. So what I'll do, I'll just select the line and I'll just take the distance from here. Okay, so this is the line I joined. Now this one I just need to rotate it. Okay, and right click, select the point and just right click, copy that one and make it rotation of 90 degree here. Okay, now you can see this is the joining point of this. Now from here again we need to join this to the last, like from this to this point. So this is what tangent we drawn. Tangent need to be drawn here actually, and let me join here line here to the this point. Okay, and this one we can just squeeze up to here. Yeah, and these things we can again rotate this. You can rotate this, select this point, right click, copy, and we can give 180. Okay, so now you can see this is the, let's change the color of this and some thickness of this also. So this is our tangent of that. And what about the normal? So this one, what I'll do, again I'll just rotate it and select this point, right click, copy that and give an angle of 90. Okay, so this one again just I can extend it or I can copy it again also. Okay, so same thing can be done for this. Now this one we can reduce the length, that much not required. This also you can reduce it. Okay, and now we need to give the text of this single line text. This is our here T dash, and this is our T, and this is N, and this is N dash. Okay, so like that we can complete the tangent and normal on the parabola. So I hope all of you understood how to draw it. And one more dimension also need to mention here, from this point to this 70, because that is given in the question. This is the distance from the directrix, 70 mm. So I hope all of you understood how to draw it. If anyone having doubt, you can give a comment on the comment box. Thank you all.